So today we're going to be taking everything, putting it all together, and learning how to solve proportions. Now we need to remember that unequal masses will not balance on a fulcrum or a scale if they are an equal distance from the middle. One side will go up and the other will go down. However, unequal masses will balance when the following proportion is true. So mass 1 over length 2 is the same as mass 2 over length 1. So basically taking length 1 and mass 2 and mass 1 and length 2 and balancing each other out. Now one way we can find whether ratios such as those on the previous slide are equal is to find a common denominator. So for example, 6 over 8 and 9 over 12. 8 and 12 both go into 24. We can create a common denominator and we find that they are actually equal. However, finding common denominators is not always the simplest, and sometimes it's time consuming. So another way we can solve proportions or figure out if they're equal is something called cross products. Cross products and proportions are equal if the ratios are not in proportion, the cross products are not equal. So for example here, if we did 6 times 12, it's the same as 8 times 9. They are both 72. Here, same thing. So 5 over 2 and 15 over 6. 5 times 6 is 30. 2 times 15 is also 30. On the right side, we see non-proportional, like 1 times 7 is 7. 6 times 2 is 12. Since 7 isn't equal to 12, they're not proportional. Same thing here. So let's look at what this looks like. Here we have 6/15 and 4/10. We're going to create a cross product. 6 times 10. We're going to see if it's equal to 15 times 4. Well, 6 times 10 is 60. 15 times 4 is also 60. So yes, these are proportional. Now how do we use this in real life? A mixture of fuel for certain small engines should be 4 parts gasoline to 1 part oil. If you combine 5 quarts of oil with 15 quarts of gas, will the mixture be correct? So it was 4 parts gas to 1 part oil. And we want to know, is that proportional to mixing 15 quarts of gas with 5 quarts of oil? So here we're going to multiply 4 times 5 and see, is that equal to 1 times 15? Well, 4 times 5 is 20. 1 times 15 is 15. So these are not proportional, so the mixture would not be correct. Now it's your turn. Why don't you go ahead and pause the video and see if this proportion is correct. Alright, so 5 times 4 would be 20. 10 times 2 is also 20. So yes, these are proportional. And here's another one for you to try out. Pause the video and see if this one is correct. So a mixture for a certain brand of tea should be 3 parts tea to 1 part sugar. And we want to know, is that the same as 12 tablespoons of tea with 4 teaspoons of sugar? So we have 3 times 4 is 12. 1 times 12 is 12. So yes, the mixture would be correct. We can also solve proportions using unit rates. So here we have one item, a price for 15 items is the same as $48 for 3 items. So since we're paying $48 for 3 items, we are paying $16 for 1. So our unit rate is $16 for 1 item. So since we're buying 15 items, we could take 16 times 15 and we get $240. Now it's your turn. Why don't you see if you can solve this one? So first we're going to start with our unit rate. So since it's 60 for 4, it's once again going to be $15 per item. This time, however, we're buying 18 items, so I'm going to take 15 times 18. And when I do that, I get $270. Another way we can solve proportions is by using equivalent fractions. So here we can ask ourselves, how do we create an equivalent fraction? Well, since 3 times 7 is 21, if I multiply the top by that same number, I get an equivalent fraction. So 1 times 7 is 7. So here y would equal 7. Now it's your turn. Go ahead and pause the video and see if you can solve this one using equivalent fractions. So when we look at this one, since it's 4 times 4 is 16, I'm going to take 3 times 4, so y is going to equal 12. Now in reality, you can use any of those methods, and sometimes other methods work better than the others. It just depends on the problem. So let's go ahead and solve this one on your own and use any of the methods that you would like. J&A department store is selling 3 pairs of children's socks for $5. Mrs. Wagner wants to buy a dozen pairs of socks. How much will this cost? So since it's $5 for 3 pairs, then we want to figure out how much it would cost for 12 socks. Now in this case, it might be easiest just to do an equivalent fraction. So since it's 3 times 4 is 12, I could do 5 times 4, and x would equal $20 for 12 pairs of socks. Go ahead and pause the video and try this problem now. So here, we're paying $7 for 6 light bulbs. And if they want to buy 3 dozen light bulbs, so 3 times 12 would be 36. We want to know how much that would cost. Once again, we could use equivalent fractions. Multiply the bottom by 6, multiply the top by 6, and we get $42 is equal to our cost for 3 dozen light bulbs. Alright, go ahead and pause the video and try this problem now. Allison weighs 55 pounds and sits on a seesaw 4 feet away from its center. If Marco sits 5 feet away from the center and the seesaw is balanced, how much does Marco weigh? So mass 1 would be Allison, and she weighs 55 pounds. We're trying to balance that with Marco, but we don't know his mass. Now remember, it's always the opposite length. So if Allison weighs 55 and sits 4 feet away, 4 is actually going to go under mass 2, and Marco is 5 feet away. Now in this problem, using equivalent fractions isn't really going to work, so we could use cross products. If I do 55 times 4, or we could use unit rates. That equals 220, and that has to be the same as 5x. So now what I'm going to do is just solve the equation and divide both sides by 5, and we get that x is 44. So Marco weighs 44 pounds.